notation. Focus. Focus, camera. All right, camera. Okay. I don't like the fact that we made a radical. We didn't need to. What's the other way to write a square root? We talked about this before. A square root can be written as a what kind of power? Fractional power. So a square root cuts things in half. So this can actually be written as this. And now do you see how directly that's saying cut 8 in half? When you raise something with a power to a power, you multiply the powers. Yes? So 1/2 times 8 is 4. That's a much better thing. But unfortunately radicals exist, so oh well. Okay, maybe.
Why did they exist?
See again?
Why did they exist?
It was just invented and it caught on, right? So the history of math is a whole other thing. So every now and again I'll bring up some. I looked into that a while back. I can't remember exactly, but it was sort of invented at the same time that they made the fractional powers thing, and they both sort of caught on. So it's sort of like the U.S. is the only country in the world that doesn't use the metric system. There used to be 3 countries, and the other 2 said, I think we'll do the right thing. And so we're still special. But anyway, so this also tells you it's 8 and 4. Okay, so the real question is, what the shit? What is something like this? Can you just tell me exactly what the answer is?
Y square root 2.
Be quiet. I mean, can you just give me a number? No. Right? If it was the square root of 49, the answer would be 7. But it's the square root of 50, so I can estimate the answer to be 7.03, so just to pretend like I know. It's going to be a little more than 7. Is that cool? But, okay, that's not good because I don't know how to do that. I can't do that by hand. Is there something we can do? So, for example, if I said, what is 16 over 40? Instead of doing long division, what is one thing we can do by hand? Reduce it. Put it into a better form, right? So we can't do this by hand, but we can do something like reducing it. Okay, I like it. So why does this reduce real quick? Because there's a part of this that is also in this. There's a part of each that works. So here, is there a part of 50 that I can do the square root of? 25. So square root of 50 is the square root of 25 times the square root of 2. Is that cool? And then square root of 25 is 5, and we all catch up to what you said. I like it. Does that look familiar? Do you guys remember doing anything like that? Simplifying radicals?
Old time ago.
Long time ago, I understand. But again, let me make a little bit more directly relevant problem. If I had, you can do it, Jeff. If I had 50 divided by 75, I can't do that without getting a decimal. I can't do this without getting a decimal. But this is 25 times 2, and this is 25 times 3. So I do the part I can, and I leave the part I can't. I do the part I can, and I leave the part I can't. It's the same idea. Maybe. Okay. And again, just to remind you guys, if something I explained still doesn't make sense, you can ask follow-up questions, right? I'm looking at your faces, and you're all, okay. So, anything else from chapter 1 before I get into chapter 2? So it's kind of important that you get into homework and start trying to do some of those so you can come with questions, right? In fact, to kind of, well, I'll just let you know, next Wednesday, I'm going to have a quiz on chapter 1. Yay! Okay. It's officially, right now, I'm closing the book on chapter, sort of, right? I'm going to start lecturing on chapter 2. So when is the homework sort of due? 2 classes later, which will be Wednesday. That's kind of how I put my quizzes, is when the homework should kind of be done. All right. So, chapter 2 is all about solving equations and inequalities. So let me go back a step here. Bum, bum, bum. Yeah, equations and inequalities, blah, 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 blah. Okay. And that's all I'll say about that now. So basic equations, hopefully, we're pretty good. It's also got some graphing stuff in there. Did I get in the right place? I think it did.
Yeah.
Yes, okay. So let's first talk about just solving equations. Then we'll talk about inequalities, and then we'll talk about some graphing stuff. Okay. Are we all? Let's see. Just take a second, and can you guys solve this? Start with a nice one. Yeah. All right. I'll do it in a different order. Ooh, there's the couple of others. Oh, that's the time on that. You're good. This is perfectly situated. What's the first step? What's the overarching idea of solving an equation? You're trying to get what by itself? Isolate the x, right? Trying to get him to isolate. So normally you try to get all the numbers on one side, all the x's on the other side, right? And you can choose which side to go on. So what's a good first step here?
+7.
Okay, you can add 7. Get my numbers over there, so this goes away.
Subtract 3x.
And then subtract 3x. So you want your numbers on one side, letters on the other side, because my goal is to get x equals number, because then I force the equation. I always like to think of it as the equations under that spotlight, you know, like a detective brings somebody in, tell me where you were on the night. So we're like, equation, tell me the answer. So that's basically what this is we're shaking the equation down. And then the equation says, oh, yeah, all right, it's 9. Okay. And then how do you check that answer? Plug it in and see if it actually makes something that makes sense. 4 times 9 is 36, minus 7 is 29. 3 times 9 is 27, plus 2 is 29. So it does work. I like it, right? So that's nice. That's gotta be a gimme problem, okay? If you have any trouble with that level of problem, come see me. Okay. You want every problem to be this. If you don't, it's a problem. Okay. So what about, let's try another one. Let's try one that's a little more interesting. Slightly more, here, the second one. There, I'll start numbering. What you got, Jeff? 4 times 3 minus x plus 2 equals x minus 3 times 5 minus x. That's funkadelic. Ooh, I like it. That's gonna be neat. Funky. All right, so this sort of came up yesterday or the day before. Whenever we're simplifying an expression or solving an equation, where's the main place we sort of start, if it's there? Distribution. I love it. Because everything in here is currently stuck. I can't do shit with them because they're stuck inside this thing. I need to free them up. Free your mind. I need to free them up so I can move stuff around and get like terms together, right? So what do I get here?
12 minus 4x.
12 minus 4x. And somebody else help me out with this one. And what you got to be careful here. What's actually going through? Negative 3.
Negative 15, positive 3x.
Negative 15, I love it. And then negative 3 times negative x is plus 3x. Kick ass. Kick ass. All right. And now I'm almost in a place that looks like the first problem. I just have some simplification to do on each side, right? What can I put together here?
Well, that's
12 and 2. Now watch this real quick. All right, everybody, pick your pencil up. Don't write anything down. Just watch. I always get somebody do this. Can you explain to me why you think somebody does this? Always get somebody doing this. Do you see what they're doing and why they're doing it? When would I do this if I'm trying to move something to the other side? This is together already. 12 and 2 is 14. Shit. What did you just do? You just subtracted 4 from the side and left the other side alone. That's not allowed. You're not allowed to just change one side, right? But I understand. It's like over there, so you think, I got to move it. No. The equal sign is what you got to move things across, right? Okay. 12 and 2, 14. That's crazy. Over there?
Negative 15 plus 4x.
Okay, I like it. Or like this, either way. Okay, and now it looks just like the earlier problem. Now I just got to pick a side for x's, pick a side for numbers, right? You can either always put the x's on this side or move them so they're positive. That's what I normally do. So here I would add 4x just to keep them nice and positive. And then what would you do?
Add 15.
Add 15 because you picked that side for the x's, so you got to get the numbers on the other side. And then you end up with a beautiful answer. What's the last thing you almost always do? Divide. Exactly. You don't want that 8 there. It's multiplying the x, so I divide it to kill it. Is that the answer you wanted? No, it's like that, man. It's the answer you need. So, please leave it as a fraction. There's no reason, unless the instructions say make it a decimal, whatever. Just leave it as a fraction. Reduce it if you can. Can I reduce that? No. And real quick, what would that be as a mixed number in case you needed it as a mixed number? Does anyone know how to do that?
3 and 4/5.
3 and?
4/5. Or 3 like
3 and?
3.5.
What does 8 go into? That's
5/8.
there it is. Let me show you a different way to do this. What do you wish this number was? What's the next number down that you wish it was? That would go with 8.
24.
24. So isn't this 24 plus 5, right? What's 24 divided by 8? 3. What's 5 divided by 8? I don't know. No. Right? And again, that's just what remainder is. That's all that remainder is. 8 goes into 29 3 times with 5 left over 8. Left over 8. Okay, I know. Okay. All right, so what about, this is where things get exciting. Couple things that make this exciting. Notice that we're going to talk about complex numbers in a minute, right? And I've got a nifty little video I'm going to show you. Has everybody got this here? Okay. So here's the deal. Let's do it I'm going to do it in a different order than that. How would I solve this? Actually, let me do this. I tell you, if I tell you 2 numbers multiply to be 8, can somebody tell me what they might be? 1 and 8, is that what you said? What else? 2 numbers multiply to be 8, what could they be? 4 and 2. What else? -4, -2, right? I said numbers. 1/2 and 16. Are you guys with me? So how many possible answers are there if 2 numbers multiply to be 8? Infinite number. Shit. So do I want to be given a problem where 2 numbers multiply to be 8? No, because then I have no idea it could be anything. Holy crap. If I tell you 2 numbers multiply to be 0, there's something that must be true. There's no question. What must be true if 2 numbers multiply to be 0? At least one of them has to be frickin' 0. I really want you to understand what I'm just saying. If 2 numbers multiply to 8, infinite number of things. 2 numbers multiply to 0, I know that one of them at least has to be 0. I know something for sure, right? So if I have x minus 1 times x plus 4 equals 0. Can you guys see the two numbers? There's two numbers up. What's one of them? I love you guys. No. There's two numbers multiplying up there. What are they? X minus 1 is a number. Do you guys understand what I'm saying? Isn't X minus 1 a number? It's just a number I don't know yet. You tell me what X is, I know what X minus 1 is. It's a number. What's the other number? X plus 4. What did we just say? Since they equal 0, we know something for certain. What must happen? Either this is 0, or this is 0. If this was 8, I'm screwed, right? I can maybe kind of guess and check, but if the answer is 7.2839, I get to guess and check that. But if it's 0, no guessing. I really want this to make sense. Are you guys cool with what just happened? No? So two numbers multiply to 0. Either this first number is 0 or the second number. That's the only way this thing works, right? If neither of them is 0, ain't going to be 0 as an answer. So what does this give you? 1 or -4. Now some of you guys might realize that the problem wouldn't start like this. The problem would start as a quadratic, and then you would factor it. So this problem specifically would have started off looking like this. And then you would factor it, and then you can do this. No? Yes? Maybe? Okay. I really want you guys to, even if you forgot how to factor, can you see how that makes sense? I want you to realize I can solve this equation all day because I can get x by itself. The minute I do this, I am screwed. Can I get my x's together? Because they're not like terms. Shit. So I need a different method to solve that kind of equation. And this is the method we created. All right, so let's try. That one's not going to work nice. That's gross. Let me make one that's a little bit nicer. All right, so we got this here. Okay. So let's start off with, so then we have to remember how to factor. Okay. So if I have something like this, x squared plus 11x plus 30 equals 0. So again, you can't get x by itself because you can't even get the x's together. So you need another way to do this. So how do I factor this thing?
Is this where you do the x with the product and the sum?
You could. Since this is a 1, you really shouldn't need that. Because what do I need? I need two numbers that do what? They multiply to 30
And
add to 11. Right? Is that cool? Okay, I like it. And really quick, why? Why do I need that? Because whatever these numbers are, isn't that where 30 is going to come from when I multiply them? And whatever these numbers are, don't I get the middle terms and they add to make this? So of course I need two numbers that add to be 11, multiply to 30. And what are those numbers? 5 and 6. It's a little number game, right? So I get x and x to make x squared. And now I know 5 and 6 are what make these happen. And now I've got it set up so I can do like we just did. So what's got to happen? Either, x plus 5 is 0, so x equals -5. Or,
X equals -6.
x plus 6 is 0, so x equals -6. Right. And how do you check that? How do you check those? Plug them back in. It's the beautiful thing about any equation you look at ever. You can just plug this shit back in and see if it makes it true. And then you can check it. All right, and again, real quick, let me say this right now. Because I think some of you guys look a little bored. If you're cool with all this shit, appreciate that. Just sit there and appreciate it and go, I know this is fantastic. I love it. If you've forgotten some of this stuff, ask questions. Right? Yes?
So are you always going to get like two answers out of this? The
Really cool. It's like I planted it. Notice how the highest power is the second power. There's something called the fundamental theorem of algebra. Fundamental freaking theorem. I threw the freaking in of algebra. And what it says is the degree of your equation is the number of answers you will get. Now, some of them might be complex, imaginary stuff, right? Some of them could be repeats. But you are guaranteed to get that many answers. So if I had a cube in my equation, I should get 3 answers. Some of them might be freaky as shit, but there are 3 answers. That's kind of nifty, yes? That's kind of nifty. That's why we call that the fundamental freaking theorem. Well, I call it the fundamental freaking theorem. Okay. So good observation. All right. Let's do the next level up from here. That's basically what math does, right? It says, here's this, and now here's the next, and then here's what can really happen. Let's do this. What you got, John? Sure. What's going to make this work? I like. So what's kind of wrong about something here? It's not equal to 0. So what is it that really, if that wasn't here, would I need it to equal 0? No, I could just add 10, divide by -5, right? The higher power being there screws the whole thing. And now I've got to think, shit, I can't just get x by itself. I need to make a 0 and then try to factor. That's what tells me when to do that, when I see a power bigger than 1. Maybe? I can't, some of you guys I never want to play poker with. You got this. I'm not going to tell you if I understand. Okay. Okay, that's fine. I'll deal with it. So, what's the first step then? Add 4. And now, there's nothing wrong with this really, but what do you not like about this problem? The fact that it exists, sure, I understand. But there's a freaking 4 there. Shit. Okay. That makes the factoring harder because it could be 4x and x, or it could be 2x and 2x. All right. So, let me give you, let me see. I'm going to try to give you a little motivation. I think I'm going to put some more sheets up in Canvas. I got to remember to do this. When I teach factoring, back in the day when Math 90, Math 110 existed here, yeah, I'm never going to let that shit go. All right. I would give what I call motivation sheets. And what it would be like, why the shit does the factoring thing we do work, right? Why should I expect the method we use to work, right? So I'm going to put those sheets up in case anybody's kind of forgotten how to factor and wants to know why the hell we factor the way we do. It's not just because we said, let's just make them do this. So watch this real quick. You can do it, Jeff. So to get motivation for factoring, what I do is I look at it the other way. This is already factored, correct? How do I multiply it out to be not factored anymore?
Distribute.
Yeah, so what do I get here?
6x
6x squared
squared.
plus 4x minus 15x. All right, now watch, this is so cool. Please go with me on this. Please go with me on this. What is 6 times negative 10?
Negative 16.
What is 4 times negative 15?
Negative 60.
Okay. If anything, I could put any numbers here and that would have happened. So what I'm saying is, this is why this process makes sense. I put these together. Oh, get out of there, Jeff. Okay. So, I don't need factors of 10 or negative 10 that add to be negative 11. I need factors of negative 60 that add to be negative 11. So when there's a number in front, I have to take it into account. So normally, if that wasn't there, we would find factors of negative 6 that add to be negative 5, right? That's what we would do. It's not a 1. So that messes with this. So now I need factors of negative 24. And yeah, you can do your little X thing if you want. I still don't understand how that helps, but shit, go ahead. I need factors in negative 24 that add to be negative 5. And that's not too bad, right? What's that?
Negative 8 and 3.
Negative 8 and 3. And I said the other day that unless you can explain to me, this is where some teachers just tell you to divide by 4 here and do some weird shit. You're not allowed to do that with me unless you can explain why that shit works. I don't let you use magic. This ain't no Hogwarts or anything. I don't care. I like that joke. I'm going to keep it. Okay. So what do? I basically do this backwards. I take the middle term and break it up. I take the middle term and I break it up. Like this. Minus 8x plus 3x minus 6. Let me stop for a minute. Some of you guys are like, yes, please stop. Now I've got how many terms? How many terms?
4.
4. What do I do when I have 4 more terms? Group. What comes out of the first two?
4x.
4x. And what's left?
X minus 2.
I love it.
3.
3.
X minus 2.
How do I know I'm on the right track? Because these are the same. If they weren't, you did something wrong. Erase, back up, right? And so what does it become at the end? I can take this out. And what's left if I do that?
4x plus 3.
4x plus 3. All right, we're not done yet, right? It's an equation, so I'm not done until I know what x is. So let me stop there for a minute. Is this coming back? Is this familiar? If you're saying no, you need to come see me, right? Yes?
Where did you get the 8x and the 3x? I don't understand how you went from 5.
Were you cool here?
No, I don't know how to do that. I don't know how to do this thing.
Oh, screw that thing. All right. So, you kind of made me happy. Do you understand what I said about you have to take this times this, right?
Oh, okay.
Because normally, I really want to make sure if it was just this, I would find factors of negative 6 to add to be negative 5. Because 1 times negative 6 is negative 6. That's why the 1 doesn't screw with anything. Since there's a 4 there, I can't do factors of this, make this. I need factors of negative 24 to add to be negative 5. And that's negative 8 and 3, right? Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5.
Yeah.
So, real quick, isn't negative 7 plus 2, isn't that negative 5? But the grouping wouldn't work. These are the only numbers that will make the grouping work. Okay. So, we'll do another example of this in a minute. I'm almost done. Put this up here. So now I'm at the point where I can do what? I'm sorry, go ahead.
Before you move on, how did you go from 4x, x minus, no, the line, the second line?
Sure.
It's 4x, parentheses, x minus 2 plus 3, and then x minus 2. How did you go?
Oh, I love it. Okay, real quick. Help me out. How would you factor this? It's a nice one. Don't overthink it. How would you factor it? What can come out? A y. Is that cool? Why can a y come out? Because they both have a y. Yes? So since they both have a y, somebody must have distributed a y, so I'm just going to undo that. Right? That's all it is. Are you with me? Doesn't matter. If I would have put an a there, would that have really changed? It would have just been an a there. So what if I put a x minus 2 here instead of a y? Don't they still both have an x minus 2? I can still take that out like we did, yeah? Okay, that's a good question because it gets weird when you see more shit, but that x minus 2 is just a number. The same way y is just a number. It just looks more complicated, but who cares? It's one thing. I like it. I like it a lot. So then how do I, now we're at the same place we were before. How do I finish this?
minus two
this.
equals 0.
Yeah, I
4x
got
plus
something
3
times
equals 0.
something is 0, so either the first guy is 0, or the second guy is 0. So then you get either x is 2, or x is subtract 3, divide by 4. Is that cool? You could do the steps if you want to. I just want to get there. Maybe. Okay. Yes.
Can you explain one more time how you got 4x into the parentheses?
Here or
Yeah.
here?
Yeah, right there.
Oh, okay. So again, one more step here, right? So whatever's here, I can take it out.
Right.
If I would have put an A. If I would have put a Z. If I would have put a happy face, right? So I have an x minus 2. So if I take an x minus 2 out, what's left here, if that's gone,
The 4x.
4x. 3.
Okay. Okay.
See, and if you put it back in, don't you get x minus 2 times this?
Yeah.
X minus 2 times that? It doesn't. When you start to go backwards, it works.
Right.
Yes.
So I know how you said like for quadratics, there's always gonna be two answers, but what about like a perfect quadratic? Wouldn't that just be one answer?
Oh, I see. We're going to do that. We'll do a quick problem like that next. I like it. So I was going to do that, or I was going to do one more complicated factor problem. So we'll do that next. Because remember what I said. They could be repeated, but there's still two answers.
Two answers, yeah.
But it's repeated, yeah. Okay, so that's that one. So what he's talking about real quick, and just to remind you guys, 1 and 2 are a review. They're chock-a-block full of stuff. First few classes are going to feel a little bit like we're all over the place, I know, because we got a lot of little things to review. But then when we start to get into the actual content, we're going to do topic, right? You guys with me? I just want you to think the whole semester is going to be me, and then this other thing, and then this. No. Thank God for me too. Okay. So what you're talking about is something like this. This is a nice one to factor, yes, because what do you need? Two numbers that multiply to 9 and add to be -6. Because I know the first piece is x and x. There's no question. Just the numbers I need to think about. So yeah, I heard it already.
-3 and -3.
-3. So don't you get x equals 3? X equals 3? So if you're a normal person, and I said, what's the answer? You wouldn't go, well, the answer is 3 and 3, right? You would say the answer is frickin' 3, Jeff. So it seems like there's one answer, but there's 2. They just happen to be the same, right? I really want that understood. Okay. I like it. By the way, quick little side note. If I graphed this, what would it look like? Like x squared stuff. I see somebody tracing it out in the back.
Would
Yeah.
it be just flat,
It would be a
is that the?
Oh, there it is. Parabola, right? So look. When I have a parabola, it can either have 2 places that equal 0, like this problem did. So this parabola, if I graphed it, it would go through the x-axis twice. What about the problem we just did? It would look like this. It goes through the x-axis once. Now, what's another way of parabola? We couldn't a parabola never go through the x-axis at all? And that would be no real solutions, but there are, of course, imaginary freaking solutions, yes. Complex solutions. Yay, Jeff! Sorry. I know everybody kind of dislikes, so it's bad naming, it just is. I think I told you about when we first came up with negative numbers, people thought they didn't exist, and we now know a lot better. They exist, holy shit, my bank knows all about them, right? Okay. Maybe, are you guys all right? You guys look a little shell-shocked. Okay, maybe, no? Okay. Let's do this. Let's talk a little more directly about factoring itself. So let's do another example like the one we just did up here. just the factoring. Let's just focus on factoring. So I'm gonna make a problem and I'm gonna make it work. And I'm gonna do something kind of weird to make it. I gotta do something kind of weird to make it work. Let me see. Okay, this will be good. Okay. I gotta think ahead to get the middle to work out right. Let's see if I did that right. Yes, okay. So what is it about this problem that tells you it's gonna be a little more complicated than another kind of 3-term deal?
Eight.
Yes, the fact that the first number is not a 1. It's gonna be more complicated. So I don't find factors of -10 that add to the -11. I find factors of -80 that add to b. So you can make the x if you want to. Yes?
Is it always the first and third number?
Yes.
Okay.
In fact, this is called the AC method. What the shit is AC? Not air conditioning. Isn't a quadratic written like this? The AC method. AC method. Yes.
So you said it's just like the only time that you would do A times C is if there was an actual number besides like it being
And I really
1.
want this, I said this really quickly earlier. Remember we did this one earlier? What's A in this case? What's here?
1.
1 times -6 is -6, and that's why we just look at this. So I actually always multiply by this number. If it's a 1, we sort of don't say we do, but we still do. You always do. Yeah. So 8 times -10, -8. I need factors of -80 that make -11. So you might have to think about it for a while. I'll let you use a calculator. 5 and 16? And which one's gotta be negative to make this work? The bigger one's gotta be now, like. David? Now what I always do, it doesn't matter how you split this up. You can either put the 5 and the 16 or the 16 and the 5, doesn't actually matter. So what I normally do, if I have a choice, I put the -1 first. Because when there's a negative in the middle, it messes up that second piece. It makes it easy for me to make a mistake. I don't know if this makes any sense. So I'm going to put the -16x first, and then the +5x next. Did I change the problem at all?
No.
Nope, it's still the same. Right, math is like, all right, whatever. It's still -11. But what are we allowed to do now? Grouping. And grouping should be relatively easy. It's just GCF a couple times, right? Okay. So 8x squared minus 16, what comes out of these? 8x. So we got 1x left here minus 2. And what comes out of these guys? 5. X minus 2. And so I know I'm on the right track because those are the same. So then the answer will be x minus 2 times 8x plus 5. Sure. Let me see if I can make something nice. Oh, that's right. Let's do, yeah, all right. Go on a little trip with me for a second. You know, like, just do it, math boy. All right. All right. I'm gonna pick a number. I can pick. Can I pick any number for x? What is x in this equation? It's not an equation. It's just a statement. X could be anything, correct? You guys cool with that? X could be 17.2 billion. X could be 0.3. Yeah? So I'm gonna pick 4 just because. It could be anything. And what I'm about to, you don't have to do what I'm about to do, ever. Just want to show you once. If x is 4, what number is this? 8 times 4 squared, 8 times 16 is 128.
24?
Right? 8 times 4 squared, right? 8 times 16. I think I did that in my head, right? 11 times 4? 44. Minus 10. Now, for those of you out there that are silently thinking to yourself, where the shit did 4 come from? I made it up. I can let x be whatever the hell I want to be. Right? Do you have to do that for the problem? No. We're done. We're just doing weird extra shit just because, right? So if x is 4, this number is whatever the hell that is. I don't know. What is that? 74? Thank you. If x is 4, what is this number? 2. And if x is 4, what is this number? 4 times 8 is 32 plus 5? 37. How do you factor 74? 2 times 37. So again, I think I did this once with you guys before. When you factor a variable expression, you are factoring an infinite number of numbers. If you let x be anything, this is a number and this is a way to factor it. Do you guys kind of get what I'm trying to say? So there is a concrete aspect to this weird-ass abstract x bullshit that we do. There is. Because x could be any number. Okay, all right, that's all right. I'll let that go. Okay. We're not going to play any poker, ever. Now, let's talk about, well, let's do this. Let's talk about quadratic formula real quick. Everybody's favorite in the universe. And basically what quadratic formula is it's a shortcut to solving this. Does anyone remember quadratic formula?
Negative b plus or minus the square root of b squared minus 4ac over 2a.
So, let me think. I was toying around with the idea of actually showing you where this came from. You can actually do the work. You can actually show how this, it's not just something we said, let's make it this. We actually solved this shit. We solved this and got this. And why is that good? Because it works for whatever A, B, and C are. Except, of course, what can A not be?
0.
It can't be 0, you see? Because if A was 0, would it even be a problem I need help with? No, that's easy as shit. So if A is 0, this doesn't apply. Is that cool? Okay. So real quick, if I do this for that problem, what is A, what is B, what is C?
A is 8, b is negative 11, c is negative 10.
Right? Pretty simple, just what's in the right place. And then you just plug that stuff in. So see what we get. We get negative 11 is 11. Give or take. Square root of b squared would be 121, right? Negative 1 squared is 121 minus 4 times 8 times negative 10. All over twice 8. All right, that looks yummy. So I get 11, give or take, negative 4 times 8 is negative 32 times negative 10 is plus 320. 320 plus 121, 320 plus 121 is 441. There it is, Jeff. All over 16. Holy shit, Jeff. Square root of 441. Oh, God. Believe it or not, you could do it. Right? No. You're out there saying, I can't do that. But it does come out nice. Does anybody have a calculator? I know what the answer is. I think it's 21, right? Yes, okay. 21. So that's an example of a number that you would think would never work. It actually comes out beautiful. All right, let me stop for a minute. Is this familiar?
I'm a little bit confused where you got the 4 and the 2.
4 and 2.
Like 2a and 4ac, negative 1.
Oh! Okay. Maybe I'll show where this comes from. This is the result of solving this. I didn't show you just the solution because you should have seen this before, right? I can show you the solution. Might not be a bad idea because I got to explain something else anyway. All right. If I finish this out, how do I do this? I do 11 plus 21, 32 divided by 6, or 11 minus 21, negative 10 over 6. So then I get, what's 32 over 6? Did I do that right? 11 plus 21, yeah, 32 over 6.
16, 11, 3, 16.
16 over,
No, about,
what's that again? Oh, 16, thank you, that's what's messing me up. All right, that's better. 32 over 16 is just 2, that's better. And negative 10 over 16 is negative 5 over 8 if you reduce it, is that cool? And wouldn't you get 2? And wouldn't you get subtract 5, divide by 8, negative 5/8? So what does quadratic formula do? It solves quadratic equals 0. Okay, maybe.
So
Maybe.
this is, that stuff in the red writing is the same as what we did on, over here on this side?
Yeah, this would be, if this was equal to 0, we would have gotten exactly these same answers. Now personally, that's easier for me. But a lot of people just do this automatically without even trying that, which makes me sad. Little tears come out. Okay. So let me do this. Yes, okay, I'll do that. I'm gonna show you a method to solve quadratic equations that sometimes happens. I think I showed you, remember up in Canvas? Didn't I put the factoring worksheet up in Canvas?
Yeah.
And I also put a solving quadratic equations handout up there. So it's got what I'm about to talk about. It's called completing the square. Does anyone remember something called completing the square, right? It doesn't mean I draw a square and then you draw the last line, right? So we'll talk about what the hell that means. And then we'll do complex numbers and we'll watch a little video. So let me ask you something. Why is this equation you don't have to FOIL this out to solve it. You do not. Does somebody see how I can solve this without having to FOIL it out? What's the worst part? What if it wasn't there, this would be a one-step problem. If the frickin' square wasn't there, wouldn't I just add to and be done with it? Stupid square. So the neat thing about equations, if you see a part of the equation you don't like, very often you could just kill it by doing the same thing to both sides. What kills a square? Square root. Now, little side note. Can anybody tell me what you squared to get 9?
3.
It's not what I'm thinking about. It's not the answer I got. Nah. It's either 3 or?
-3.
Ah, shit. So, if I take a square root and I just put the positive, I'm not getting all the answers. So the minute you take a square root, you got to put a little plus or minus, because of course it could be negative, because the square would kill the negative. Does that make any sense? So taking a square root of both sides is a shortcut. And almost every shortcut comes with a little concept you have to understand. It's kind of like the give or take. If you want to have a shortcut, great. Just don't forget to do this. And in this case, it's putting the plus or minus. Does this sound familiar? A little bit? Okay. So, if I take the square root of both sides, die. But on that side, plus or minus. And of course I get plus or minus 2. So either x minus 2 is 2, or x minus 2 is negative 2. So I get x is 4, or x is 0. Is that cool? And why does it make sense I got 2 answers?
Plus or minus.
Squared. Highest degree is 2, I should get 2 answers. Okay, I like it, maybe. Okay, so what does this have to do with quadratic equation? I don't know, we're not there yet, hold on. So if the equation is in the form something squared equals a number, it's relatively easy, yes? Because I take square root, put plus or minus, blah, blah, blah. So, motivation. Okay. I know this is not acting class, don't worry. We're not going to all get up and perform skits. I know some of you guys are like, I want to, please let me do that. No. Help me out. What is x plus 3 squared? It's not x squared plus 9, so don't tell me that. How do you do x plus 3 squared?
X plus 3 times x plus 3.
I love it. So what do you get? Oh, yeah, this thing. Sorry.
X squared was 6x plus 9.
Yeah, so if you need to, you can, of course, write it twice. But you should maybe be able to think in your x times x squared. 3x plus 3x is 6x. 3 times 3 is 9. How does 9 relate to 3? It's 3 squared. How does 6 relate to 3? It's 3 doubled. It's twice 3, yes? Okay. Here, take a second, any way you want to, don't say it. Square that for me. Do x minus 4 squared. Do it real quick. Please. Or draw a duck. Just make it look like you're doing it. Preferably do this.
X minus 8x.
Wait, I said don't say it. Sorry. Appreciate that. Let everybody give it a try. All right, now tell me.
X minus 8x plus 16.
Almost, but it should be x squared.
Squared minus 8x.
11. How does 16 relate to negative 4? It's negative 4 squared. How does negative 8 relate to negative 4? Twice negative 4, right? Is there a pattern here? It seems like the middle one is that last number doubled, and the last one is that number squared. Yes? Okay, so. And this is the real fundamental of what math is about, is noticing patterns and then making rules out of those patterns. So I don't have to do the whole thing every time. I can just use the rule I made up. So if I have x squared plus 10x, what would I have to add to it to make it factor nice? Oh shit. So again, the middle term, how did it relate to this number every time? It was double that one. So what should this number, I know that's an x, yes? I just don't know what this number is. That number has to be 5. So the first step, take this, cut it in half. That is what goes here. Now I need to know what to put there. 25. That's right. Because the last number is this number squared. So how do I complete the square? Take the middle number, cut it in half. That's what goes here. And then I square what I got. That's what goes here. Is that a true statement? Yes, Jeff. Okay, so how do I use this idea? Let's do one more, just to make sure we got it. Here, you guys do this real quick. I'll make that A. Here's B. X squared minus 12x. And now you see why it's called completing the square, because I figure out what goes here so that it can be written as a square. Completing the square. So you guys try to do this one. The 2 steps here never, ever, ever change. Cut the middle in half and then square it. Here we go. And just so you know, this is from my Math 108 a while back, but here is a whole worksheet about what we're doing right now. Right? Yeah. And on the back is just a collection of how to solve any quadratic, including quadratic formula, right? So that's up on campus. So what's the first step? I take negative 12 and I cut it in half. Yes, what do you get?
Negative 6.
Holy shit. And then I take negative 6 and I square it and I get 36. So the first one tells me what that's going to look like, and this one tells me what to put here. And then you can kind of check it and it makes sense. So what the hell does this have to do with a quadratic formula, for example, Jeff? What the hell's this shit got to do with the freaking ABC bullshit? And secondly, what does this have to do with solving an equation in the first place at all, Jeff? Come on, man. All right. Give me a second, geez. Oh, sorry. So, try to solve x squared plus 10x equals, let's make it, sure, let's make it something gross. 2. Right. Notice if I subtract 2, I can't factor it. So, and this normally I would teach this before we even talked about quadratic formula, so we wouldn't have a clue about quadratic formula, okay? So I don't want to subtract 2. What I really want to do is to make it look like this, because then I can take a square root, right? So didn't we just do this one? What would I have to put here to make it actually factor? Yeah, I'd have to put a 25, right? Half of 10 is 5, so that's what this is going to look like. Squared is 25. Now, if I add 25 there, I better freaking add 25 there. So that's the thing with an equation. You got two sides. You got to make sure you keep things balanced. Okay, maybe? So again, all I was missing was the number. Half of this is 5. That's what this is going to be. Squared is 25. That's what I add. So now I know this is this. And what do I get on that side? And now how do I finish this up? Take the square root. Die. Plus or minus. Let's see if you guys can do this. You can do something to this. How can you simplify that? 9 and 3, right? What's the square root of 9?
3.
What's the square root of 3? I don't know. Third base. No. Abbott Costello? Yes.
How did you get, like, where'd the 25 go?
Oh, 2 plus 25.
Oh.
You're good, you're good, you're good. The 2 is already over there, so just, you know.
Right.
Okay. And then, of course, the last step is just to subtract 5. It's almost nice when you get a radical because you just have to write the whole thing out. You don't have to actually put anything together. You're done. I don't know what this shit -5 plus or minus 3 rad 3 is. They're not like terms. So I'm good. Okay. Yes?
And you always put, like -5, you always put it in the front?
Yeah, it's convention to put the plus or minus in the middle.
Okay.
Yeah. It's just convention. It's not really wrong if you don't, but it's going to look wrong to me, but I'm not going to take points off. All right, so now, oh God, all right. You guys have enjoyed everything so much. I know you're about to enjoy the hell out of this. We're going to take ax squared plus bx plus c equals 0. We're going to solve it. When I say we, I mean me, really. You guys can watch. All right. So yeah, just do it, man. Shut up. All right.
Wait, I have a question.
Yes.
For this method, completing the square, will this method only work if x squared does not have a number in front of it?
Beautiful, thank you. That's what I was about to show you with the, yeah, you're good. Yeah, completing a square is hardwired to work if there's a 1 there. So if there's something other than a 1, I have to divide it. I like it. So that's what's going to happen to us right now. You're going to love this. Okay. All right. Okay. Please just try to stay with me. You don't have to write this down if you don't want to. You're fine. Just try to kind of stay with me. Okay. So like we just said, it's hardwired to need a 1 here. So I'm going to divide by a first. And of course the 0 just eats the a. So already it looks just fantastic, right? Okay. Just go with me. The great thing about processes like completing a square, it almost doesn't matter how gross things look. You just frickin' do the steps. It kind of works itself out. It's going to look gross. Who cares? You just put stuff where it goes. There's a whole process. So what is the process? Let me first subtract this. I got to make room here, right? Because I want to cut the middle in half and add what I need. So I'm going to subtract that over. Make some room here at the end. Got it. Right, just subtract it over. So subtract it to the other side. I got some room now. I know some of you guys are like, How did it work? How did we get 5 here and 25 there? I took whatever was in the middle and I cut it in half. Okay. Let me do that over here. First step, take what's in the middle and cut it in half. So don't I get b over 2a? If I cut b over a in half, I get b over 2a. Isn't it already starting to look like parts of the quadratic? Okay, a little bit, maybe. That's the first step. What's the second step? I take that and what's the second step? Square. That is what I have to add to both sides. Now listen to me. I know that looks gross as shit. That looks gross. Am I doing anything different than we did earlier with the numbers? No, I'm doing exactly the same thing. Looks gross? Who cares? I added this here, I better add it over here. Now the nice thing with completing the square is I have to factor this. I already know how it factors. Right? Why did we put a 5 there? Because half of 10 is 5. So what am I going to put here? What was half of this dude? It was this first step always tells me how this factors. Square. Again, just watch. It's okay. Every step, I'm doing the exact same thing, correct? It just looks gross. And I know I keep saying that, but this is not hard. It's just gross. I do the exact same thing. How do I combine these two things? They're fractions, so what do I need?
Like terms?
No, right? So what does this guy need that this guy's got?
Square.
He needs another a, so multiply by a, and he needs a 4. So then I get b squared minus 4ac, okay, so all over 4a squared, yes? And now that I got crap squared equals stuff, how can I kill the square, of course? Square root. The minute I put a square root, I have to put a plus or minus. So I get x plus b over 2a equals plus or minus, now help me out, what's the square root of 4a squared? 2a. And then I just subtract this over. And don't they have LCD? So I can just make it, subtract this over, so minus b plus or minus square root of b squared minus 4ac over 2a. Okay, there's where it comes from. Right? Is that, no? Were you the one that asked me about it? Where the 4 come from and stuff?
Yeah.
Okay. I can't write, but that's. So now at least you saw where it does come from a specific place. It isn't just shit we threw together and said, let's teach them this shit. No. It actually is the answer. Now a really interesting question is, if it had a 3 there, is there something similar? There is, but I'm not going to show you that. That's insane. I could show you sometime. It's got imaginary numbers in and stuff, but yeah, don't worry. Well, we just stopped here. So, let's do this. Let's do a couple things, and then we'll see where else we want to go. You can do a jump. Okay, let's do that next. So that's this. You don't need to write this down. I just want you, I'm glad you asked, I want you to see at least once where the hell this thing comes from. Right? It actually is solving the ax squared plus that. Okay. Let's talk about imaginary numbers, which is a horrible name. Let me show you something really. Oh, let's see if you guys are cool. Let me show you something kind of cool. Why, when you multiply two negatives, why is it a positive?
Because they cancel out.
Why?
My math teacher told me so.
I like it. That's good. But I don't like that at the same time. Okay. When you multiply by a negative, I think of it as turning halfway around. So visually, multiplying by a negative turns you there. So 1 times negative 1, 180 degrees. So what if I do negative 1 times negative 1? when they go from here 180 degrees back to 1. So if I said, turn around, now turn around again, aren't you like facing the same way? Okay, so 2 turnarounds should bring you back to normal. Yes? Maybe. Does that make any sense?
Yes.
Okay, now, here's where things get weird. Okay. Imaginary numbers are not imaginary. They exist. Without them, we wouldn't understand electricity, for example. Right? We have to use imaginary numbers to describe what's called voltage waves, which is how electricity functions. But we're not going to suddenly learn electromagnetism, don't worry. What if I were to say, okay, I don't want to turn a full 180. What if I want to do half of -1? What if I want to multiply by half of -1? That means I end up here. So half of -1 would be the square root of -1. Now, why is that a problem by itself? What is the square root of -1? Huh?
Undefined.
Yeah, it's not really undefined. It's just not real. It's completely defined. It just isn't real. So what's unfortunate is when we teach math, we pretend like that's nothing because we want to focus on real numbers. But that's not nothing. It's not undefined. It's a number. Because let me ask you this. All right, I don't know if this... So a full 180-degree turn is multiplying by a full -1. If I turn halfway, I multiply by half of a -1. So what if I did halfway again? Where should I end up? -1. So that means if I turn halfway and I turn halfway again, what happens to the square roots when I do this? What's the square root of -1 squared? What do these two do? The square root and the square, what do they do? Kill each other. So don't you get -1? So sure enough, if I do 2 quarter turns, I do end up at -1. Okay. So this is a number squared is negative. That's one property that imaginary numbers have that we're completely not used to. Right? Every other number we've ever talked about when you square it, it's positive. Yes, or 0, right? Yeah, I love you guys. You guys kind of, how many of you guys feel like you've never discussed imaginary numbers before? Anybody? Oh shit, I'm sorry. Okay, all right. So right now you're feeling a little freaked out, right? Maybe? Okay. So what we do, just to make it easier to write this stuff down, we call the square root of -1, we decided to call it I. Sort of like we call 3.141596 blah, 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 we call it pi. Yes? Same kind of idea. I just didn't want to have to write all that shit down. This thing looks weird, so let's call it I. So what did we just figure out that I squared is?
1 or
No.
-1?
-1. So I squared is -1. Yeah, I like it. And if you just, I wish I would have been taught, when I was taught this, the idea of turning. So if I do a quarter turn twice, I should end up at -1. That's why that makes sense. Now, on one level, that doesn't make sense, because I never squared something and got a negative ever before. But I never defined something like what I is defined to be. Okay, maybe? Okay, so let's see how this works. I'm gonna do this. Let's see how this works in the wild. What if I had this problem? How do I solve that? Don't worry about the negative, just what do I do?
Square root.
Square root. In the minute I put a square root, I put a
Plus minus.
plus or minus. Now somebody help me out. What's the square root of 4? 2. So let me break this up. Is this cool? So the square root of 4 is 2. And what do we define the square root of -1 to be? I. I love you guys so much. Okay. Let me start over again here. if I add 4 over, can anyone tell me anything about, we talked about this earlier, what would that look like if I graphed it? It's a parabola. Can anyone tell me what the y-intercept would be? When do I get the y-intercept? When x is 0. Does that sound familiar? So what do I get when x is 0? I get 4, don't I? So isn't this a parabola whose y-intercept is 4, but it opens up? Yes? So when does this have an answer? When is the parabola equal to 0? When does it hit the x-axis? At no real number does it do it, right? There's no real answer here. It doesn't go through this real axis. But, oh, I love you guys so much. What the idea of this was this is the real number line, and this is the imaginary number line. So this would go like 1, 2, and this would go I, 2I. So there's a whole other thing next to this number line that we don't see. Because when we graph this 2D plot, we're only graphing real shit. We're only graphing the real numbers. Thank God we don't graph the imaginary numbers, because that gets weird. Okay. So let me do this right now. I'm going to show you a video. So I need to turn you off because it's going to be all copyright business.